Sine, cosine, and tangent are defined to be functions. What that means is if you put a single number into something like tangent in either degrees or radians, you're only ever going to get one number back. And you can check this if your calculator is in degree mode. Tangent of 45 degrees is always equal to 1. It'll never be equal to anything else. Same thing goes if you're using radians. If you plug in pi over 4, you also get 1. The reason for this is these are defined as the ratios of sides in a right triangle. To simplify things, I'm going to look at a 45-degree angle in a triangle and talk about why tangent of 45 can only be equal to 1. So down here, I'm going to draw a triangle with a 45-degree angle, and it will be a right triangle. So here I have a right triangle. If this side is length 1 and this side is length 1, then this must be a 45-degree angle. By definition, tangent of 45 degrees, it's the ratio, meaning a fraction, of this side divided by this side, which is 1 divided by 1, and that simply equals 1. So that is where this number comes from. You'll never get anything else. You'll always get 1. If you think it's a relative value, it might be because you can draw multiple triangles that are different than this one that also have a 45-degree angle in it. So like, for example, what if I extend the length of this side by 1, and I also extend the length of this side by 1, and I draw a triangle here of side length 2 and 2. I'll do that in red, so I'll extend this one here, and I'll extend this one here, and then now this is the triangle that we're referring to, this larger triangle. It still is a right triangle. The side is now length 2, meaning this is length 2 and this is length 2. But what's the angle that we have here? This angle is still a 45-degree angle. So this time, if you want to evaluate tangent of 45 degrees, but from the larger triangle that is in red, it's the ratio of the opposite over the adjacent side, which is 2 over 2. But the thing is, it always simplifies down to the single number. And I can do this one more time. I'll draw a triangle that starts here and goes out a distance of 3, and then goes up a distance of 3 in this direction. If you trace out this triangle, I'm doing my best to draw it, so the opposite side is length 3, the adjacent side is length 3, but it's still the same 45-degree angle. So here we have that, again, tangent of 45 degrees. This time is equal to 3 over 3, but that still simplifies to 1. The reason that these are functions, meaning you only get one output for every given input, and not different outputs, is because you're canceling the common factors when you divide one side by the other. The other thing that appeared in homework 4.3 was solving an equation like this. Now, when I chose this homework problem, I wasn't thinking inverse functions, but I'll explain what that means in a little bit. I was thinking of a guess and check approach. Can you think of an angle that goes in place of theta that's equal to 102 over 105? So 102 over 105 is roughly about 0.971. So in a calculator, what you could do is type tangent of some number that you guess, and if you get something close to 0.971, well, that angle is likely the solution to the problem. The thing is, you can use an inverse function to speed up this process so you're not guessing and checking. And that's what happens in the MyLab math. It actually uses the inverse function so you can get the answer quickly. Before I show you how that works, this is probably a process that you've seen before, just with other functions. In fact, let's say you wanted to solve the equation 10 to the power of x is equal to 117. You can use a guess and check approach. I know 10 squared is close to 100, so the answer is probably something close to 2. But there's something programmed into your calculator that will solve this thing for you. What you can do is, to both sides of this equation, is use the inverse of 10 to the x. What is that inverse? We call it the logarithm, so log. So you take log of both sides. So log is a button on your calculator, and it's specifically defined so that if you take the log of 10 to a power, those things cancel and it just leaves you with x. And in fact, the exact solution is log, which is log base 10 of 117. You can now go to your calculator, type in log 117, and it will give you a really good decimal approximation. I just checked this, and I got that x is approximately equal to 2.068. The decimal goes on, but In a calculator, you can get the answer to this very quickly without guessing and checking. And if that still isn't something that feels familiar to you, it's also very similar to if you were to solve the square root of x is equal to 3. You want to do something that undoes this square root, and the operation that we have for that is squaring both sides. If you square the left, the square root of x squared is simply x. Squaring undoes the square root, and on the other side, you get the value 9. So these two things here, if using inverses, there are already functions defined for tangent. What is this called? It's called tangent inverse. So in this equation, what I'm going to do is apply tangent inverse to both sides. On the left, that looks like tangent inverse of the left side is going to be equal to tangent inverse of the right side. On the right side, we have the number 102 over 105. And on the left, we have tangent of theta. So again, this tangent inverse function is defined to cancel, to undo tangent. Like those two things go away, and you're just left with theta. On the other side, you have tangent inverse of this number, but this is something that you can type into a calculator. My calculator is currently set in, I believe, let me just check. Oh, it's not. I'll change it to degree mode. And what I'm going to do is just type in this expression. So I'm going to do tangent inverse of 102 divided by 105. And the value that I get back for theta is approximately 44.1. If I round to 2 decimal places, it's 17, and this is degrees. So anytime that you approach something where you could solve it by guessing and checking, it's very likely that there's some inverse function that can do this work for you, and it can do it very quickly. There's definitely a lot of subtle details with tangent inverse itself, and this will be explored later in this class.